very well known and common problem of integration. The value of Sn, which is given by integration 0 to pi by 2 sine of 2n minus 1x by sin x dx, where n being an integer is given by. We first tell the answer. This is the answer, okay, because it is well known and common problem of integration. How to solve it? We first find Sn plus 1. So this is 0 to pi by 2. We put n plus 1 in place of n, so we get this is 2n plus 1x by sin x dx, right? Now if we find Sn plus 1 minus Sn, and this is given by 0 to pi by 2, we directly write the result sine of 2n plus 1x minus sine of 2n minus 1x by sin x dx. Sorry, this is dx, right? Now clearly this is sine of a plus b and this is sine of a minus b. So using the formula we directly write the result 2 into cos of 2nx into sin x by sin x dx, right? Now sin x cancel out, so the integration is 2 by 2 into sine of 2nx here n, okay, because 2n here, so we write 2n, and the range is 0 to pi by 2. And it is clear that if we put pi by 2, then we get sine n pi, which is 0, and sine 0 is obviously 0, so the result is 0. So we get from this relation Sn plus 1, this is Sn. Now if we replace n by n minus 1, so we get this is equal to Sn minus 1 from this recurring relation, and similarly we get this is S1. Now what is the value of S1? We put n equal to 1 here, then this is 0 to pi by 2, this is sin x by sin x dx, because if we put n equal to 1, then the numerator is sin x. So this is integration 0 to pi by 2 dx, and this is pi by 2. So obviously Sn, this is equal to pi by 2. Okay, this is very easy integration and well known and common integration, and very important problem also. Okay, thank you for watching.